Hi, everybody. Welcome to this session, Personally Identifier Information Removal in Discussion Board Data. And we are a comprehensive team coming from Learning Engineering Institute, Ed Plus Action Lab, and Enterprise Technology. And here are our beloved teammates, which I will introduce later also. Haley and Ethan are here. And my name is Lillian. I'm from the Learning Engineering Institute, and we are a team consist of researchers, data scientists, data engineers, and here is an overview of why we're so interested or why there's a need to remove personally identifiable information from the discussion board. So starting from the why, the what, how we do it, and data sharing. So first of all, why we're doing this project. So we are a team working for the Learning at Scale data sharing platform, which is a platform that share educational data from ASU that has millions of roles to educational researchers to facilitate their research. And in particular, we really want to share our discussion board data with researchers because discussion boards are often a key component in a lot of instructional design or online courses. And also they offers insights into student engagement, and they can answer a very crucial question that whether online engagement or discussion board could be beneficial to student learning or not, or in what occasion it will be beneficial and in what occasion it does not. And also making it available can not only benefit educational researchers, but also NLP researchers, as well as in nowadays, large language models are booming. They could potentially be the training and fine-tuning data for building up generative bots too. However, protecting students' privacy is also very important. When we are looking into the discussion boards via ASU Canvas, we often saw a lot of PIIs in the discussion board posts. A lot of classes have introduce yourself posts that contain, a lot of students will introduce their names, where they're at, and what is their phone number and email addresses. And if these information are made public available, then it could be a potential like very high risk for students' privacy. And also, a lot of professors will give feedbacks using students' names to address students. And also, some regular assignments are assigned as discussion board posts, and a lot of students will have their assignment, title, the date, and also their names on it. So these are all these PIIs that we would definitely not want to share with the public. And then what is defined as PII? Now we're referring to the FERPA, the Family Education Protective Act, and the PIIs are defined as direct identifiers such as names and ID number and phone number, and also indirect identifiers such as student date of birth and also their location, and any kind of information that can distinguish one individual from another. So based on the definition of the FERPA and also our discussion as a group of experts, we identified 10 categories of PII to remove, including direct identifiers, indirect identifiers, and also other relevant information that could potentially leak students' identities, such as their organizations and their professions. And our goal is to develop a data set of 250K Canvas discussion entries with students' PII removed. And also the data will be made available to internal and external researchers. And now I'm handing it over to Haley to tell us about how we do the identification.
Thanks, Lillian. So the overall process started with us pulling the data from the enterprise data warehouse. After that, we did some basic pre-processing, the actual PII removal itself, evaluation of both the model itself and the resulting data, and then the final data share. For the PII, for the pre-processing, we removed any HTML, CSS, or URLs that were present. And the purpose of this step was really to just make the data set a little bit easier for researchers to use. The next step was be the PII removal itself. And in order to do this, we first had to create a labeled training data set. And we did this because we wanted to fine tune the model specifically to work for discussion boards. So we use the tool Docano, which is an open source tool that basically just provides a user interface to help make these labeling tasks easier. Using Docano, we labeled over 4,000 discussion posts. Each of these posts was labeled by 2 different people. And the purpose of that is if there was any discrepancy between the 2 different labelers, we had a third person come in and fix that particular discrepancy. The next step was to fine tune the LLM. So this is actually OpenAI actually makes this pretty easy. There's about 4 things that you need to provide OpenAI to do this. Your model information, so like the model you want to use, the temperature, the system prompt, which you can see here on the screen, the input data, and your expected output data. So in our case, the expected output data would be a subset of all of those posts that we manually labeled. The next step, once you have your model fine-tuned, is you want to review the actual model itself. So we use some classification metrics that are pretty standard for these types of classification models, including precision, recall, F1. And we compared these results to other tests that we ran. So we also tried some more traditional named entity recognition methods. We tried few-shot learning, and we also tried zero-shot learning. And the fine-tuned model outperformed all of those other tests. So at this stage in the process, we have a fine-tuned model, which we've tested, but now we also want to evaluate the actual output data set. And one way that we evaluated this data is that we used known PII. So known PII would be names, emails, addresses, phone numbers, any information we have about the person who made that particular post. So what we did is we ran an exact match search for this information on the output of the anonymized LLM results. And anything that was flagged, we ended up dropping. So when we looked at a sample of these records that were flagged, not all of them were actually known PII. A lot of them were false positives, like the example you see here on this screen. But just for safety reasons, any that were flagged were dropped from the final data set. Another evaluation that we ran was a hallucination check. So we compared the raw input that we gave to the model to a cleaned version of the output. Theoretically, the clean version of the output should be exactly the same as the model input. Anything that was different indicates that the model incorrectly changed the discussion board text. So you can see some examples here of some of the changes that the model made when it hallucinated. So it would change some numerical facts, add in a couple words. Occasionally, it added its own PII tags that were incorrect as well. So there was a wide variety of hallucinations that we found when we did a manual review of these records. But in general, we categorized them into 4 different areas. The first was just punctuation changes. The second was just space changes. The third was text changes. And the fourth was any combination of the above. Now, some of these changes were actually very, very small. For example, you see there was a lot of space changes. The space changes would occur when, for some reason, you may have, say, 4 consecutive spaces in a discussion post for whatever reason. Sometimes the model wouldn't return 4, sometimes it would return 3 or 5. So it's not a big change. So in that scenario, we just flagged the record. And In that scenario, we give the researchers the opportunity to say, hey, either I don't want to use this in my data, or it's not a big deal, I can keep it. Anything that was a bigger change was dropped from the data set. A third test that we did was just a small test using ASU's secure Create AI platform. So Create AI is a platform that allows you to build your own LLM bot. And we use this bot to send a sample of the already cleaned records to ask an LLM, hey, did we miss anything? Was there any other PII present? Now, this was just a small test, but from this, no additional PII was found in that sample. And with that, I'll pass it over to Ethan.
Thank you, Haley. Well, now is the very exciting point for researchers and any sort of product developers here. We didn't want this project to just be in a silo. We wanted this to actually be useful to the larger community. So we kind of have a data sharing process put together for this right now. First of all, we are actually developing an official publication for an analysis on this data. Once that gets released and published, we're going to be gaining IRB approval to actually have this on the Learning at Scale platform, which I'll talk a little bit more about here in a second. Which once it's on that platform, researchers, internal and external, will be able to actually gain access. So there's going to be two caveats to this. The first one being that the researcher will have to submit an IRB to get approval to actually use this data set. And then the second is if the researcher does find any sort of PII that we might have missed within the data set itself, they have to, one, report that to us, and two, ensure that's not actually included in their publication itself, just so we can make sure we can iteratively improve this and ensure that no student information is actually leaving the data set itself. So just to give like a little bit of a teaser for what the data set all includes, we ended up curating this based on engagement factors and then also the richness of PII that might be included in the data set. So when we're working in the data warehouse, we had a bunch of different features such as like verbosity, engagement scores, reply depth, any sort of metrics that you could extract out of the millions and millions of discussion posts that we have. We included that so we can make sure to curate what we consider like a very dense sample of contextually rich student information. So within the current version of the data set that we do have, we're looking, like Lillian had said, to include almost 250,000 posts. This is going to be across 16,000 plus different students, all the way back from fall 2018 when Canvas was first implemented, all the way up until spring 2025, which is when we started working on this project. And then this is going to be across a vast range of courses too. So we're going to have 25 different subjects, over 40 different individual courses themselves. So when you are using this data, you can have a broader diversity of the different types of subjects in the posts you might see from students. We also want to include students with different sort of performance backgrounds. So this could include students that received A's in the class all the way to E's, and then even students who withdrew from the course as well. As for some of the demographics we might see in this data set, we're going to see a large minority representation, 40%. We also are going to see about a 35% male to 65% female split. And then lastly, of students with different citizenships, we're going to see nearly or over 100 different countries represented within this. And then, so unfortunately, like I mentioned, this is not currently available on the Learning at Scale platform, even though it will be very shortly. We do, however, have lots of other data that is available to researchers. So this can be done, like we had mentioned, through IRB access. So if you end up submitting an IRB to the platform, we can end up getting you all sorts of different data, lots of it regarding sort of student profiles, student trajectories. So this could be like demographics, how the students performed, aggregate measures about the class. So, you know, how many students participate in discussion board posts, you know, what's the actual like click activity around the course itself, enrollments. And so this can help sort of kind of get that initial research started and help build the base to what these courses can then join onto as well. So with that, I'm going to turn it over to the question and answers. We have a little bit of time for people to ask questions, but we want to say thank you for hearing out the project. And yeah, we really hope that this can be something that everybody can use in the near future. So any initial questions that we have? Yes. You want to speak that?
That's a great question, and thank you for bringing that up because it takes 3 RAs and also 3 expert adjudicators about 3 months to label all 4,200 posts. And a lot of posts are, as you can see, the assignment posts from English 101. So it's quite lengthy. So it takes a lot of time. I all the posts are based on English, so that's a good point, though. I think it's very possible
It's
to.
very possible that we could do that, especially as potential. Yeah, so that is a feature that would be possible. Just for right now, to sort of build the process when it comes to actual labeling and fine tuning of the model, we wanted to stick with some of the English and some of the areas we were already familiar with.
One part of that one part of that labeling process that ended up taking a little more time than I expected was that comparison between the two different people. You'd have scenarios where you could have a post say, hey, I go to Scottsdale Run Club. One person might label Scottsdale as a location, where another person might label Scottsdale Run Club as an organization. So you'd have to spend a lot of time addressing those two different conflicts during the labeling process as well.
And also, since Haley mentioned the differentiation of location and organization, it's actually quite difficult to label or differentiate these two. So you can see a relatively low precision and recall and F1 score on these two categories. However, for names, it is pretty accurate. So judging by the results, we are pretty confident that we captured most of the PIIs, while the other things like organizations and locations, they confuse human beings too. So let alone GPT.
Yeah, so that was a great question, and that was one of the big first questions that we had when approaching this project. Because there is so many different posts from different courses, different use cases, we kind of picked some standard ways to at least to measure the text. We're lucky we have a lot of great NLP researchers around us, so we into the logic that we use, we kind of implemented different sort of textual representations, I guess you could say, so that we could measure certain posts based on these things, and then we would essentially score them and rank them, and then include those posts that had, like, I guess what you would say is like the nearest similarity to what we were looking for in that. So I don't have like all of the details listed like in these slides, but there's a humongous list of different things that we did want to check on, just so that we were curating the best posts for this task.
So we're not doing that at this time. And the reason for that is it could come from multiple sources. So you could have some of these posts could be an assignment, and that assignment might be somewhere else on campus. It's not always going to be like a reply to a professor's question in a Canvas discussion. We do have information about the course itself, but nothing for a specific assignment.
Yeah, I was going to say this is something we've been kind of like thinking through recently. Like, we're very fortunate to have that partnership with them, and to have so many resources at our fingertips. One of the things we have kind of like suggested in that case is there are sort of like local open weights instances of these models that you could fine tune. And so that would probably be like the best first step to look at when it comes to these, because, you know, a lot of the times, especially with some of the new models that have been released, they're actually pretty comparable in performance. So when it comes to this step, like I think that would probably be like the best, you know, first way to go about it, especially because it'd be a lot more feasible from like the technical side of things as well.
Yeah, I just want to add on to Ethan's point that there are actually a lot of outstanding open source models, open weights models compared to the one that we use, GPT-4o. There's a new one is the GPT OSS 120B, which is an open weight model that it's very cheap. Or if you train it yourself, you can train it just using the GPU power, and that is all the cost. And also another direction we're looking into is how could we make this model open by potentially some distilling methods. And also a specific way is that we can potentially use our model to generate synthetic data so that that could be the fine-tuning data set for a open source model. So that could be a good way, good next step for us to do. That's true.
Exactly.
Any other questions? All right, thank you so much for joining our talk. And I guess we can give each other some minutes back for our next session.